Okay, so in this video we're going to try and find the particular integral of this second order linear differential equation, and after that we're going to try and prove that it's the correct solution, and then we're going to find the general solution after that. So we've done some other examples of this, so if you check in the link below you'll see some links to some other similar style questions of this using exponential and also quadratic. Right, okay, so first of all, we're looking for y as a function of x, because we've got our y's here and our x's here. So what we're looking for is y of x, and it's going to be the sum of our particular integral and our complementary function. So I'm going to call that yp for the particular integral, and I'm going to add that to our complementary function of x. Going to come on to that a little bit later. Slightly different technique to how we find the particular integral. So we need a format for our trial solution for the particular integral. So yp of x, as we got a trig function here with an input 3x, and we've got derivative and second derivative. When we take the derivative of sine, we're going to need cosine as well. So we're going to need two functions, two parts of our solution, our trial solution in here. So two terms. So we need a constant because we don't know how many versions of sine and cosine are going to be in this side, because we've got a 4 and a 5, and we take derivatives and so on. So a times sine 3x, and then we're going to need another constant, and then cosine of 3x. Okay. So that's the place to start. Next thing we need to do is we've got y prime here, so our trial solution will need to be differentiated. So now we need to differentiate this. So y prime p of x, so that's our first derivative. So take the derivative of this, that's pretty straightforward. Using the chain rule, we've got 3a cosine 3x, and then this one here, b cosine 3x. Well, cosine gives us negative sine, and then the chain rule again. So this plus will become a negative. So that's going to be negative 3b sine 3x. So that takes care of this term. Now this term here is the second derivative. So we now need to take the second derivative of our trial function. So second derivative of this. So cosine gives us negative sine. So that's going to be negative. Chain rule again, that's going to give us 9a sine 3x, and taking derivative of sine will give us positive cosine, so this minus will stay, and again chain rule gives us 9b, obviously 3 times 3 times b is 9b, cosine 3x. Okay, so now all we need to do now is plug these into these as our trial solutions and make it equal to sine 3x. So here's the first stage, what we do now. Let's plug that in. So we've got minus 9a sine 3x minus 9b cosine 3x. So let me put that in a bracket so we can see that that equates to this term. So I'll put a little arrow showing what we've done. Now we want this one. So put an arrow there. So we've got minus 4 is our coefficient here. And then we need to multiply that by this, which is our y prime. So that's 3a. I'm just going to go along here because we're going to need a bit more space. 3a cosine 3x minus 3b sine 3x. So that takes care of that term. And now we want this one. So now this one, so continuing on, we've got minus 5 times our trial function, which is a sine 3x plus b cosine 3x, and then that just equals sine 3x. So that's pretty straightforward. So I'll put these in a box so we don't get confused and mixed up there. Okay, so now we've got a load of sine 3x's, cosine 3x's, all along. And we've got these coefficients here multiplying each one. So now let's just simplify this off a little bit and just make things a little bit easier for us to read. So minus 9a sine 3x minus 9b cosine 3x. That's straightforward. Now we'll distribute the 4 into this. So minus 12a cosine 3x. So 3 times 4a. And then 4 minus 4 times minus 3b. That's going to give us a positive 12b sine 3x. And now we're going to distribute this 5. So that's minus 5a sine 3x and minus 5 times b cosine 3x, and that equals sine 3x. Okay, now what we're going to do is we're going to separate all the sines and cosines. So now we're going to do sine 3x first, because that's the first one on the line. So sine 3x, and now all the coefficients for the sines of 3x's I'm going to put in this bracketed term. So sine 3x here is minus 9a. Here we've got plus 12b. And here we've got minus 5a. So if you multiply all that out, you'll still end up with the same sine values in here. So now we're going to do the cosine. So I'm going to add cosine of 3x. So now all the cosine coefficients. So I've got minus 9b, minus 12a, and minus 5b. And that equals sine of 3x. Now at this stage, we want to look at the coefficient here for this sine of 3x. Or we could just put a 1 in there if we wish. So when I do the next line, that will become apparent as to why I've done that. So this sine of 3x, so this here should basically equal 1 times sine 3x. So this should equal 1. So that should equal 1. And here I could put cosine 3x in here. But I know that my coefficient here is going to be 0 because there's no cosine on the right hand side. So then therefore this should equal 0. So this should then give us a system of equations where hopefully we can solve for a and b. So minus 9a minus 5a, so that gives us minus 14a and 12b. So now I've got minus 14a plus 12b. That should equal 1. And now this side, I've now got minus 12a minus 14b equals 0. Okay, so this is good old-fashioned simultaneous equation. So if we can try and get some of these numbers to have the same amount, then when we add or subtract, we get one of them to disappear. So I reckon if we multiply everything by 12, that'll be a good start. So let's multiply this one by 12 and put it in the middle. So that's going to give us minus 168a plus 144b equals 12. So you'll see there I've multiplied every term by 12. Now I'm going to multiply this one by, I could do 12 again, or I could do 14. So I reckon if I multiply this by 14, I'll end up with the same coefficient on the a, give me a chance to eliminate one of them. So just noting now, multiply by 12. Here I'm going to multiply by 14, so I get the a's to disappear. So minus 168a minus 196b, and then multiply that by 14, I'm still going to end up with 0. Okay, so now if I just subtract, so 168a minus 168a, those terms are going to disappear. 144b minus 196b, that's going to give me 340b equals 12 minus 0, it's 12. Okay, so now we can solve for b, that's not a problem. B equals 12 over 340. Okay, let's look for some common factors in here. Well, I know 2 will go in, so let's just try that first. 6 over 170. And I think we can go again. So we go 2 again, both are even numbers. So that's going to give me 3 over 85. And that's going to be a positive 3 over 85. So now I can write on here, let's write it here, B equals 3 over 85. So now let's plug that into one of these. I think the 0 one will be the easiest. So just bring that over here. So minus 12a minus 14b equals 0. B equals 3 over 85, so let's plug that in. So 3 over 85 equals 0. Okay, minus 14 times 3 is 42. So now I've got minus 12a minus 42 over 85 equals 0. Okay, now we're going to have our best mental arithmetic on show here to try and get this correct. So let's go minus 12a, let's keep that on this side. So now I'm going to get minus 42 over 85 equals 12a. Now to get a on its own, I just need to divide both sides by 12. So now I'm going to write my a on this side. So a equals minus 42, 85 times 12, well that's 850 plus 170, that's 1020. Okay, if I've made a mistake there, put a comment below. So now let's see if we can divide this up. 42 and 1020 are both even, so let's go one step at a time like we did here. Don't want to make a mistake. So minus 21 over 510. And now we've got both divisible by 3. So now I've got minus 7 over 170. Okay, that's looking good. So let's type that in here. Okay, so now I'm ready to put up my particular integral. So I'll rip this off the board and then put that in. Okay, so now I've got my a and my b. I can now write my particular integral up in here. So I've got y prime is minus 9. I've got minus 9 times a, which is minus 7 over 170. And then I've got sine 3x. And then I've got minus 9b. So minus 9 times 3 over 85. And that's cosine 3x. Now I've got minus 4 times y prime. So minus 4 times 3 times minus 7 over 170. Cosine 3x minus 3 times b, which is 3 over 85, sine 3x. So I hope you don't mind the curve there, I just want to avoid this box, so we'll get it all in. And then minus 5 times a, which is minus 7 over 170 sine 3x. And then our b, which is 3 over 85. Let's just put a whole bracket in there. Did I get the whole bracket in there? Minus 5 times minus 7, 170a. So now with the b, it's 3 over 85. So that's plus 3 over 85. Put a bracket around that. Cosine 3x. And that equals sine 3x. Okay. Now we've got to get our best arithmetic again for this. So minus 9 times minus 7, so that's 63 over 170 sine 3x. Minus 9 times 3 over 85, so that's minus 27 over 85 cosine 3x. And then we need to do minus 4 times these inputs here. So 3 times minus 7 is minus 21. Minus 21 times minus 4. So that's going to give us 84, plus 84. So plus 84 over 170 cosine 3x. And then we need minus 4 times minus 3 times 3 over 85. So that's minus 9 times minus 4. That gives us plus 36 over 85 sine 3x. And now we distribute the minus 5 with these ones. So minus 5 times minus 7, so that's plus 35 over 170 sine 3x. And minus 5 times plus 3, that's minus 15 over 85 cosine 3x. I'm going to use that equals sine 3x again. Okay, sine 3x, let's get them all together. So sine 3x, got 63 over 170, 36 over 85, and 35 over 170. I'm going to write it like this, cosine, then I've got minus 27 over 85, plus 84 over 170, minus 15 over 85. Okay, and that equals sine of 3x. Okay, now hopefully I'm going to end up with this being 1 and this being 0. Let me just write 3x in there just to be, I'm sure you're all shouting at the video there saying I've missed that out. Okay, let's work out this. 63 over 170 plus 35 over 170. That's going to give me 98 over 170. Just need to make this over 170. So 36 over 85 gives me 72 over 170. So that equals 1. So we know that this, for sine, that this one here is correct. And then cosine, this should equal 0. So over 85, I've got minus 27 over 85 minus 15 over 85. So that's now going to be needed to be over 170. So now I've got minus 54 minus 30 over 170 plus 84 over 170, and we can see that that is 0. So that is all correct. So we've checked our particular solution, which I'm now going to take this off the board. I'm going to write it on here so we can have a look. Okay, so now we can update our particular solution. So just going to need a bit more space. Yp of x. Now using these, I've got minus 7 over 170 sine 3x plus 3 over 85 cosine 3x. Now you could put them the other way around and put the minus in the middle. That'd probably look neater, but that's still good to go. Okay, so now I need to find my complementary function. Now the complementary function, we just set this to be a a homogeneous equation, so we set this to be 0. So now we've got y double prime minus 4, y prime minus 5, y equals 0. So now I'll just set my lambda value to the powers of the number of derivatives we're using. So now I've got lambda squared minus 4 lambda minus 5. So second derivative, so we've got lambda squared. First derivative, so I've got lambda to the power of 1. Keep the coefficient, you need that. And then minus 5, lambda to the power of 0, which is 1, so minus 5. Okay, so I've just got a quadratic here, which we can now solve. So lambda, so it's got multiplied by 5. So 5 and 1 will be our numbers we're going to need. So minus 5 will be added to with plus 1 to give us minus 5. That's minus 4. So lambda minus 5, lambda plus 1. So therefore our solutions will be lambda equals 5 or lambda equals minus 1. So I'm going to call them lambda 1 and lambda 2. So now our complementary function, we're going to use the exponential function. So yc of x, so the format for this, I've already used a and b for my constants, so now I'm going to use c and d. So c e to the lambda 1 x plus d e to the lambda 2 x. That's my complementary function. So I've set that equal to 0. And now c we don't know because we haven't got any boundary conditions, so that will stay. Lambda 1 is 5, e to the 5x plus d e. Now lambda 2 is minus 1, so that's minus x. So that's my complementary function. So I'm going to put that in a box. This is my particular integral, so I'll keep that in a box. So now going back to the very beginning, our function for y of x is c e to the 5x plus d e to the minus x. And now we're going to put this one in there first, because I'll keep my plus sign there, plus 3 over 85 cosine 3x minus 7 over 170, make that 0 a bit neater, sine of 3x. And then that will make up our general solution. So this is the general, this we know is the complementary, and this is the particular integral. Okay, thanks for watching.